Okay, thank you, students. I do want to take, yeah, sequencing problem, and that sequencing problem is um, n by m sequencing problem. Okay, so I will see whether the site is opened or not. Then after, I will explain you what that correct problem is. This is n by m problem. I mean, n jobs are there, and there are n jobs are there, and wait, I will take the indicator there. Then I close there. Yeah, see here, there are A, B, C, D, E. There are n uh, machines are there, and 4 jobs are there. Okay, so what is this is a different type of problem because usually the jobs will be given in the column wise and machine will be in the row wise. But here in this problem, the machines are given in the column wise, whereas the jobs are given in the row wise. So this is n by m type of sequencing problems. Now let us change the given problem in the usual method. Okay, so usual method means what? The jobs are in the column wise and the machines are in the row wise. Now this we have changes now. Am I correct? To that, the processing time also you have to change, and we are getting the second matrix structure. It's called modified form. So usually the students are making mistakes directly code to this problem to solve it. But that should not be the case. Okay. So what we have to do is that we have to given the matrix, we have to change into upside down. I mean the column wise as rows and row wise as the column. So that is called a modified form. Now come here, this called modified form. We have got it. Okay. The next step is that we have to, as usual, we have to find the minimum in the first machine and minimum in the last machine and the maximum in between the machines. Okay, so let us take that one. In this particular problem, the minimum in the first row is minimum in the first row is 5 days. You suppose 5 days is a minimum in the first machine, that is machine A. The last machine, the minimum is what? Uh, 6 days, 8 days, 10 days, 9 days. So 6 days is the minimum days that we have to note that. Then afterwards, what is the maximum among the time taken by B, C, D? So B, C, D, you search for that the maximum processing time. Yeah, 6 days. So 6 days is the maximum among the machines B, C, D. So that is 6 days. Okay, right. Now we have check. We have to check whether the minimum of A or minimum of the last machine is greater than or equal to maximum among the between machines. That's what next our aim. So let us check that now. Look at this. The minimum of A is greater than or equal to maximum among B, C, D. Now the minimum among A is 5 days, whereas maximum among B, C, D is 6 days. Okay, therefore this is not true. Now let us take the minimum of E is greater than or equal to maximum of B, C, D. That's what we are checking here. So minimum of E is 6 days, maximum among B, C, D is 6 days. So that is satisfied, both are equal. This is what is step number 2 we say. Now what is the next step? Step number 3 is that first machine time, second machine time and third machine time. We have to add all of them and we are taking as a first machine. And for the second machine, we are taking it as the sum of the processing time of the second machine, third machine and fourth machine. So that way we are making the total given machine as 2 machines. Okay, so let us do that job now. Now look at this here. Now G machine I am taking as G and H as 2 machine I am taking there. Now how I am framing the processing time. Look at that. 7 plus 5, 12. 12 plus 5, 17. A plus B plus C plus D. 17. Similarly, 12 plus 9. 12 plus 9, 21. Similarly, add all this, you will get this. Add all this, leaving the last one, you will get this. Now, what about hatch processing time? Hatch processing time is leave the first machine time and add all the 3 machine time. B, C, D, 4 machine time you add there. 5 plus 2, 7, 7 plus 3, 10, 10 plus 9, 19. 6 plus 4, 10, 10 plus 15, 25. Like that. Leave the first one, the last 4 processing time you add and straight to hatch right there. So this way the given 5 machines can be changed into the 2 machines with processing time of the jobs. Okay, that's what we are seeing in this particular step. Step number 4 we are getting that. For this we have to get optimal sequence. We know that what is in an optimal sequence. The given matrix is which is the least processing time is J4. J4 is the least processing time. So we can write as I already told you that comes in the H or second machine. If that is the case, we have to write that on the left hand side box. Okay, right. What is the next least time is 17. Where it comes in the first machine. So we have to write in the left hand side box. The next one is 20 days. Where it comes in the first machine. Therefore, we have to fill up in the left hand side. Already one is fixed. Now we are writing 3. The left out job is 2 and that we can write here. So actually it is better that we can write here. I forgot that. Okay, take this. Actually, this is what is J1 and this is J3. This is J2 and this is J4. Similarly here it is J1, this is J3, this is J2 and this is J1. Right. So this is the way we can optimal sequence for the given problem, which is reduced to two machines. Okay. And next, we know that how to calculate the total elapsed time and the ideal time for all the machines here. The machines are A, B, C, D, and E. A, B, C, D, and E. So we know how to find the what's that total elapsed time and ideal time. Uh, in the case of n by 2 matrix, we have done so many problems, okay, and the same way we have to do here also. Uh, so that is what you have to understand here. Now the job sequence is J1, J3, J2, J1, right. Now for A job, the in time is 0. Now go back and see there how long it takes. J1 is here and machine A is 7. So 0 plus 7, 7 days. Now the in time is 7 days. Now J3 under A machine takes 5 days. So 7 plus 5, 12 days. Then 12 days is the incoming time. And what is the outgoing time? Here, what happened there? The cursor is not working there. Time is going out. So this is the way we can calculate the processing time for a machine. Okay, so this method we know already. Am I correct? This method we know already. Wait, I will take and bring that back here and we close that. Now let me maximize so that you can see that. Right now it's okay, no? Right. Now J2, the time taken is 6 days under the machine J. Therefore, we are adding 6 days with the 12 days. You are getting 18 days. Now, starting time is 18 days. J1 takes 7 days. Sorry, it's not the J7, am I correct? It is J4. J4 takes 8 days. 18 plus 8, 26. Okay, this is we have made wrong here. It is J4. Right. So this is the way we can calculate all the total elapsed time is 51 days. And the ideal time, this we have to add with this ideal time that F1 51 minus 26, 51 minus 29, 51 minus 32, 51 minus 32. So this way we can calculate ideal time. Thank you very much.